So the project today is making an automatic linter in Python, but before I do that, I'm going to show you what happens when you try to add a non-unique key to a dictionary. So what I'm doing first is I'm pulling this line from the Zen of Python that says explicit is better than implicit, and another important thing in Python is where it says error should never pass silently. And so this is where Python contradicts itself. Because what happens if you try to pass non-unique keys to a dictionary, it is just going to pick the most recently added value with that key. And so this should throw an error about how the key is not unique. And if you didn't know this, then I would recommend looking up some other terms that are going to be mentioned in this video, because I made this video for beginners in mind, but this is a video for everybody. It's kind of up there with the difficulty. So if you're a beginner, I would recommend looking up regular expressions, what the frame stack is in Python, and recursion before you watch this video, because I'm not going to be explaining those concepts from the beginning. Because two questions that we're going to get into here, if you've ever wondered them: can you decorate a decorated function, and can you pass arguments to a decorator? Because spoiler alert, you can. It's very easy. And so going up and down the frame stack is how I managed to make something that would rewrite your script in real time and output the value that you wanted based on what you might have meant, with also still letting you know where the errors are. Because we're not trying to make errors implicit with this. That's not the goal. We're still trying to let you know how you need to rewrite your code so that it can be correct. But this is just to optimize your time. Just because spelling errors, you know that you made a mistake, you know what the mistake is going to be. It's going to be a key error, it's going to be a type error. Why not just go ahead and fix the error so you can see the output that you were trying to reach? And so in order to do that, I had to go up and down the frame stack, and yes, it is automatic. It's going to go ahead and rewrite the script, run it, and give you the output that you wanted and the error location of which line messed it up. And so here's the implementation in Dart, and it does the same thing where only the most recent value associated with the key is going to get added to the map. And that's not something I like. And whenever I define my own dictionary, and you can see that in the double key dictionary video, I don't allow this in my dictionary. So here are the problems that we're going to solve. And here are the problems I want to solve. If you want to contribute, I'm going to have it on GitHub. I want this to be a fully functional program that actually accounts for a lot of errors. And it was a lot of fun to figure out how this thing could work. But I picked these problems just to illustrate some points about coding in general and about how this program works. And so here I wrote a function that will evaluate all the problems. And here you see I have two things: the logs and the switcher. And so both the logs and the switcher are global variables. And usually I like global variables, but this time it did backfire on me using global variables, and I'll show you why. And so what the logs is for is it's going to show you where the error is, it's going to show you what the error was, and it's also going to show you this difference in how long the overhead was for my program and how long it should have taken your script to run. And so if you come from a programming language that uses a main function, that's kind of an important concept here. And in Python, it's usually you have a main function work like this, but I had to make a specialized kind of my own main function to do this. And so I'm going to walk you through it. So we're compiling whatever script, whatever is saved in the file to a code object, and we're using eval right now because I'm just compiling an expression. I'm just using eval on the expression because this is a prototype. In the second part of this video, I'm going to convert this to class, and we're going to use exec instead of eval. But this is just to show you we have a base function so that we can use logs. And switcher is used so that we can handle multiple errors and also handle different intensity, different protocols for the same error. So as you can see in my helper functions, I got check S and check capital. And so whenever we have a key error, we're going up the check S and the check capital to just see if maybe it's just a simple problem. And finally, at the end, we just go through all the attributes of what is the object with keys to see which one is the best match. I'm going to show you how we do that later. But at first, I want to show you how we're profiling. And so I'm going to show you what's going wrong with my global variables and why. And so if I run it just like this, you notice the last problem is handling 3 errors, 2 of the same kind. And this is why we're getting a stack overflow when we don't reset the logs. It's because it's not wanting to fix this second attribute error right here. And so it's going to do the stack overflow. And what happens, to show you how I know that's the problem, what happens if we just don't try to solve that last problem? I'm waiting on that stack overflow. Okay, here it is, finally. So let's get a new console. Let's cut off that last problem. And here we have it, no stack overflow. And so we won't get the stack overflow, and we can run all the problems if we just reset the logs. And so whenever I make this into a class, I'm not going to have logs as a global variable per se. Let's get to the last section. Let me show you what goes on with the global variables, and we're using different stacks. But as long as we reset the logs, we can get eval to work. And so can we evaluate 2 key errors in the same statement? And the answer is yes, we can, because we have a statement that has 2 key errors. And how this is possible is because I'm using this global variable switcher. And so here's the problem. And it did go up the switcher. And this is because we're having 2 errors in one statement that can be handled. Is because I'm paying close attention to when I'm using func instead of inner. Because what inner is evaluation. What func is the decorator for evaluation. So running inner is like running evaluation without a decorator. And so whenever I'm using evaluation without a decorator, it's like it's not going through this whole list of errors to see what protocol to use. It's just going through what it is in its local situation. And that's happening because the end user doesn't worry about what kind of errors I'm making in order to find out what they meant. I'm making controlled errors to see what is basically the best guess at what you meant from exploring the script. Because all this is iterating through globals or directories and using regular expressions on the error messages to get clues on what to pull out of directories or globals, and using a regular expression substitute statement to make that switch and try it. And so you can see here from key errors that I'm just seeing if keys is working here, if I can pull the right thing that will have the attribute of keys. And if it's not, I'm raising the attribute error. And so this also reflects a design of, I don't want to go down a rabbit hole of trying to find multiple things that you might have meant. So if this is all I'm doing to find the best guess for what might have the attribute of keys, and it's not that, then I'm only picking one winner. It's not that winner, then the arguments were too ambiguous. And every time you see the bunk argument, it's just because we're not trying to waste too much. Current working directory is, it's just going to first pop off the library name, if there is a library name, and see if just a function is what you meant. And so it solves an error like this. And it will even solve that one for a function in a subdirectory, but it won't do the opposite of that. So if you look up here at this import statement, if I had just imported scipy and tried to write z-score without scipy.stats, it wouldn't look for it. It would throw the argument is too ambiguous error, because this is what it's using for finding libraries. And so using that yield name instead of the value.magic method name is so that whenever you import numpy is something, an example like that is it will look for the alias instead of what the package calls itself. So I have this hypothesis that I don't need to have switcher for a key error, because my last protocol, what switcher 4 does, was when switcher equals 4, this is what key error does. I think it's probably better than using check S and check capital, because check S and check capital only really work for one word keys or column names, and that's too specific. It's not going to work in most situations. And so I could write a profiler to profile my profiler for reprogramming my program to reprogram programs, but that sounds like an automation rabbit hole, so I'll just check it with my eyeballs whenever I compare evaluating these 3 different problems. And so the thing to remember about this is, with all the problems I already listed with the first 2 protocols, and the fact that the overhead of these 2 is leading to this by the nature of how switcher works and how it goes down the list to solve the same problem, is that I know from this that this is not an out of the water overhead, and so I should probably just go with the highest intensity switcher. And so whenever I'm using my profiler, I don't always need to set an argument, and whenever I don't set an argument, it has a default mode of just giving log something to say. And that happens because, if you didn't know, I'm using a keyword argument, and so that's how I make default arguments. And so how can we catch multiple errors in scripts and handle more than just a statement at a time, while adding together all this overhead and printing the errors so users know where to go and correct? That's why I'm going to change my main function first. So this needs to be changed from eval to exec. And so how my function is recursive and how it has as many chances as it needs to rewrite the script is because of this variable fudge that keeps track of the errors. And so it's important that fudge never is equal to 0 except in this function, because this is the function checking whether or not the script can run without an error. And if it does, it finally gets to the sys exit. And so by only having fudge drop to 0 right here, it protects this sys exit from being called in a place where it shouldn't, where there still might be an error in the script. And you might be wondering why I have so many global variables. And this is because we're coordinating between these calls of retime print to control how many times exec is called. And so you can pass a globals argument to exec. Otherwise, is this just going to run the script and start a whole new globals that will collect how many global variables it has from the start. And so what it does whenever it does that is it tries to open up read the script again and again and again, because what I'm doing up here is I'm calling my own file to get the lines. And so we want there to be a session. We want it to start this session, and this is how we control how many times exec script is ran. Because if you can see here, the point of this whole key error and having exec right here is because we need to know whether or not there's a mistake. And so if there's no mistake, it will complete from here. But if there is a mistake, now that we have something, the error count, not the error count, but fudge is just a marker for how many times the script has run with an error. And so it keeps track of whether or not there is an error. And so if there is an error, then we know to run exec. And so however many times we need to run retime print to correct the errors, we can. And so once it can finally run without errors, it won't run the script again unnecessarily now that we know that it runs errors. So this sys exit will cut out of the base case and just end the program. And the reason why we're calling it retime print is because I do have a function for eliminating all the unnecessary print statements in a script, but it's not able to account for triple quoted functions yet. And so I haven't implemented it. Where did it go? And so here's the clear print function. And so what I want to use this for is putting it in between the exec functions, so that the only time that the print statements are being called is on that final successful run. Because like I said, this is supposed to work like a black box, and so it shouldn't be having like half the output and then running into an error. It should, whenever it finally has the whole output, it should print logs and show you what the errors were. Because right now we can go up this and see it does get the first input, and then it doesn't have the second input. And so the purpose of a programmer is to have the foresight to look for any edge cases of what might go wrong. And so I have to fix something in my main script, because if you see how this retime print calls for a global session active, and here's where we handle it in case there's not a global session active up here. And this right here is what creates the instance of my Fido. And my Fido is what calls retime print. So if you use retime print without first making an instance of my Fido through session, it's not going to have a session active. And if you don't know about scope, then you wouldn't even be able to see this coming, what's going to go wrong, because it will gladly make you a local session active, but it won't tell you that whenever you pass globals to this script that it doesn't have any session active. And so I want to be able to make this foolproof, be able to work with any kind of script that somebody might run if they want to be able to use retime print without making a session active, we need to just go ahead and have our own globals to pass to exec that defines everything that we want to define, that we want to pass to this to make sure that my FIDO isn't being unnecessarily called and we're not just going through an endless loop of making a retime print run. So we're going to change this. We're going to take out the global. And what we're doing is we're just instantiating a global that we need. And so session active doesn't need to be changed to true until here. And we change this to this. And it runs like how we want it. So if you're wondering how I was able to figure out which functions were being called from which frames and how the variables were being used, what I was doing was I was using U and D in my debugger. So if you pay attention to my variable explorer, you can see I go up a frame, I go back down a frame, and anytime I want to call the stack trace, I just use W. And so why I used all these global variables to coordinate the different executions is because to prevent stack overflow. And so my first implementation of this was when I rewrote the script from calling my current file, is I would just straight up delete the line where I called my FIDO session. And I didn't want to do that. I wanted to control it more through the different recursive calls. And so I wanted to be able to be this smooth line that will execute everything after. And that was the point of all that. So now it can work in a different script and be able to correct its mistakes. And so all it works is just by declaring the session, and it will take care of everything on the script either before or after. And the last problem I had was with the logs. So that's why I decided to just keep print all using eval and have it return a logs object instead of making logs global. And this way I can collect each error statement from each error and keep the line. But I wanted to simplify the syntax of making this statement at the end instead of making a deeply nested statement to pick out each line. I wanted to just make it an alternative an alternative key. And so what that is a data structure that I made myself. It's a double key dictionary, and I'm going to make another video about it. And so I'm glad I illustrated the difference between eval and exec for you. Eval just takes a statement at a time, and so it still works the same way as it did whether I had print all in a class or as a decorator of a function that used eval. And so now we'll return it to retime print. We'll try the function again, and so on and so forth, like I said. And so I'm going to put this on GitHub. I'm going to use ChatGPT to make the documentation and the doc strings. Let's see how it handles it. I'm going to make another video of that. Thank you for watching.